We hear a lot about climate change and carbon dioxide. What can farmers do about it? A lot, says Australian soil scientist Dr. Christine Jones, and get better crops as a result.
It's all about getting light energy, transforming it to biochemical energy, getting that biochemical energy into the soil to drive the soil ecosystem, to make nutrients available. Well, the reason that carbon is important is because all living things contain carbon. So as things live and die, they give up their carbon and then something else lives and takes up that carbon. I guess what we're talking about with climate change is we're talking about that cycle getting out of balance. So for thousands of years it's been in balance, the atmosphere and the plants and the soil and all the living creatures.
But in modern times, people have dug up and burned fossil fuels and exposed soil for farming. In fact, over a third of the carbon added to the atmosphere since 1850 has come from deforestation and exposing and oxidizing the rich carbon deposits in our topsoil. U.S. soil scientist Dr. Elaine Ingham says we can put it back though, and in a way so that much of it will stay.
So carbon sequestration, we're talking about putting CO2 from the atmosphere back into the soil in a form that's not going to be lost.
How do we do this? The same way nature did in the first place.
We've got to be photosynthesizing, so we've got to be growing plants in that soil. So CO2 and sunlight will be bound back into sugar structures. As those sugars go down into the root system, picking up all the nitrogen, phosphorus, sulfur, magnesium, calcium from the soil, building that plant material. The plants are putting exudates out into the soil, cakes and cookies out into the soil, and the bacteria and fungi utilize that material and build the organic matter back in the soil once again.
Those sugar water exudates are the key. This photo shows liquid carbon flowing from a plant root above along a fungal hypha or tube to feed the fungus below. In exchange for that carbon, soil microbes, including fungi, bring water or micronutrients to the roots, causing the plant to release more carbon.
In order to build that soil carbon, you have to be looking after the microbial or supporting the microbial communities in the soil that join all the little carbon atoms together to form humus polymers. They can't grow as well unless those microbes are there. They won't have as many trace elements in them if those microbes aren't there, and when the plants don't have those trace elements in them, they become vulnerable to insect attack and fungal attack, pathogens of all kinds. Finally, we're now seeing the light as it is and realise that we are light farmers, and that what we need to do is to harvest as much sunlight energy as possible by having as much green leaf as possible, therefore as much of the year as possible.
Because photosynthesis drives the whole system, soil should always be covered with plants, either crop plants or cover crops.
Farmers here in the United States started experimenting with 2-way covers and then 5-way covers and then 10-way covers, and now they're sort of aiming for 20-way covers. In other words, 20 different varieties of plants in a cover crop, and realising that the more diverse they make the cover crop, the faster they can build soil and the more less reliant they are on any chemicals at all.
Farmers are finding that building soil biodiversity builds plant health.
Now they're finding they don't have to use any synthetic fertilisers anymore. They don't have to use pesticides. They don't have to use insecticides. And not only are they producing food that's higher in nutrients, but it's also lower in toxic chemicals, and they're taking CO2 out of the atmosphere and storing it in the soils.
We also want resilience in our fields. Carbon builds a good, clumpy soil structure, holding on to rainwater.
And the other thing is how quickly, when the rain does absorb, how quickly does it evaporate? So when it gets into the soil, we want it to stay there. So we want to have aggregates in the soil. Aggregates are little lumps, like pea-shaped lumps in the soil, that have a much higher moisture content on the inside of the aggregate than on the outside. And we see the greatest increases in carbon sequestration through what I call the liquid carbon pathway, when it's being fixed in green leaves, translocated through the plants, exuded by roots into microbial communities in the soil and forming aggregates and leading to the process of humification, which is the holy grail for soil, to have an increase in humus in the soil.
So our job, as Dr. Ingham says, is to farm so we are working with nature.
So don't till. Could we have a list of those farmers that are no-till or zero-till, and really let people know that they're the ones doing the work?
And, as Dr. Jones says, this kind of farming is a win for everyone.
But if we can take more of the carbon that's in the atmosphere and store it in our soil, then our soils and our food production systems are going to be more resilient. But we could produce the same yield with much higher quality, with much lower cost, and building soil at the same time. I think the fundamental shift in thinking that we have to make is that farming is about harvesting light. Through the process of photosynthesis, we're going to change light energy to biochemical energy, and then that biochemical energy becomes our plants, our animals, through the carbon compounds that are made by that process. We are fundamentally light farmers, and when we make that realisation, then the sky's the limit.